Section 1, Video 4. Now let's apply our knowledge of finding the area of a rhombus. So we have two formulas for the area of a rhombus, we said. The first one was H times S, and the second one, depending upon the information you have, is 1/2 diagonal 1 times diagonal 2. Now if we look at our shape, we have the sides, which are 13, so that's good. But we don't have the height. So therefore, this one is not going to be a choice. So if we go to the other one, we look and see what we have. Well, we do have a diagonal, one complete diagonal, that'd be 10, but we don't have the other. But we do have something that we want to notice here, and that is that the diagonals of a rhombus are perpendicular to each other, which means we have 4 different right triangles. And 2 of those 3 sides of each of those triangles we have the numbers to. So that means we can go back to a classic for us, which is to use the Pythagorean theorem. Knowing, of course, which side is the hypotenuse, if the right angle is right here. So if we square and move the numbers to the right side, we would get 144. We square root both sides, and x is 12. Now remember, this is x, which goes from here to here. We want the full diagonal, which would be twice as big, so 24. Now, if we do that calculation, we should get an area of 120 with no units given. Now, what's nice about this is when we go to the area of a kite, you should notice that it's the same formula. Sorry about that. It is the same formula as a trapezoid. There's one of our 2 choices. So let's see how that works here. So we apply it down to this kite, and if you'll notice, we have one diagonal. So we're looking for the area, so area is 1/2 diagonal 1 times diagonal 2, and we only know one diagonal at this point. But if you remember, when you draw the other diagonal, they are perpendicular to each other. And this 80 right here is the full diagonal length. So that means it makes this part 40 because the vertical diagonal bisects the shorter diagonal. And we are back to Pythagorean. So 40 squared plus an unknown squared, we'll call this x right here, equals 50 squared. If we do that calculation, we end up with x squared equal to 900, square root, and x is 30. Well, that tells us this part, but we need the full diagonal, this whole thing, so we go back to Pythagorean again. And again we have 40 squared plus, and we'll call this one y, equals 120 squared. And this calculation gets pretty big, 12,800. Square root both sides, and y is approximately 113.74. We take that, now remember again, that is this length. So we take these 2 and we add them together, and we get 143.14, and that is our other diagonal. We plug that in, and we should get a calculation of 5,725.48, and we do have units on this one, centimeters squared.